Okay.
Started,
Okay.
sir.
So, good morning, one and all connected here. I would like to welcome today's guest, Susan Madam from Rajalakshmi Institute of Technology in EC department. She is working as an assistant professor. She has completed her ME at Rajalakshmi Engineering College, Chennai at 2014, and she is a university rank holder in post-graduation. She received her BE degree from Anna University, Chennai. She has published 19 journal papers and conference papers, and also she has published a textbook for Adhoc and wireless sensor network based on our syllabus. Now it is available in the market. So our research area including wireless sensor network, cognitive radio, and wireless communication. So she is a member of 3 different professional societies also. I would like to thank in this moment Susan Madam for accepting our invitation and delivering the guest lecture for our student. Thank you for your acceptance. So now I request Madam to start the session.
So thank you so much for the introduction, sir. And it's a great opportunity to be a part of our RMK and to present in front of final year students about the sensor network, as it is my area of interest. Thank you, sir.
Yes.
Okay. So you have your 5th unit as sensor network, platforms, and tools. Okay. So platforms means you have 2 types of platforms. One is a hardware platform and second is a software platform. So both platforms you are going to see today, and along with that you are going to see some tools. Tools means what are the simulation tools that you are going to use for executing the programs in wireless sensor networks. So this is a roadmap. These are the things that I'll try to cover up. So first is the sensor node, the hardware architecture of the sensor node, then the mica mode architecture, then what are the challenges that you are facing when you are doing programming, and the next is basics of simulation tools, and the last is NS2 simulation and NSG 2.1 simulation. So first 4 things are going to be theory part. I'll try to complete the first 4 sections within half an hour, and after that I'll concentrate more on the programming of NS2 and NSG 2.1, because NS2 is one of the most widely used tool for doing project in wireless sensor network. And as you people are doing your final year, last semester you will be having your project. So if I'm giving an insight of NS2 and NSG 2.1 simulation tool, it will be useful for you so that you can do your projects in wireless sensor network without any problem. Okay. So I'll be giving more concentration on NS2 and NSG 2.1. So yeah, I'll go with the next slide. Okay. So this is introduction of wireless sensor network. You know what is wireless sensor networks. Wireless sensor networks are those networks consist of many number of mobile nodes that dynamically forms a network without the use of existing network or without the use of a centralized administration. That means the sensor, this is the sensor field, and in this you have different types of sensor nodes. Okay. These sensor nodes are able to self-configure themselves. They don't need the help of a base station or a centralized administration to connect with each other. They can exchange the information among themselves. They can find the neighbor node by themselves. So sensor nodes are those nodes. They can self-configure and they can sense they can sense their neighboring nodes, and hence they will be able to connect by themselves. So here you can see that A is the source node, and you want to send the data from the source A to the sink. Sink is going to be the user. Okay, even though this is been shown as a sink, this is actually the gateway. Okay, gateway is a node that is going to connect your sensor network with the user. Okay, even though it is being shown as sink, it is going to be a gateway. Okay, it's a gateway node, and user is going to be the laptop or a PC or your PDA, personal digital assistants, or a mobile phone. It can be, the user can be anything. Okay, so sensor node will be deployed in the sensor field, and this source will get the data from the environment. Consider that you have placed a sensor node in the environment for calculating the temperature of the particular field. So A detected that the temperature is 45 degrees Celsius. So some kind of a data the sensor has sensed, and it will send the data to the nearest node, or sometimes it will be the node which is having the highest energy. So there are different criteria for selecting the neighboring node. I'm not going in deep with all those things, but for instance, we can consider as the nearest node is the node which is having the less distance. So A will sense the data from the environment. It will send the data to the neighbor node D, E, and at the end it will send the data to the gateway. Okay, gateway is a node which is going to connect your sensor network with the user, and through the internet your data will be sent to the user. Okay, user is going to be your PC. So you will be able to get the readings of your temperature of the particular field in your PC or in your computer. So this is how the communication is being carried out, and the example that I have given is a very simple example. This is very it's a very simple example, but wireless sensor network is capable of doing many other bigger applications. Okay, so sensor node is capable of doing 4 different functions: sensing, computing, storage, and communication. It will sense the data from the environment. It will compute. That means it will evaluate, or it will do some calculations based on the sensed data. It will store the data in the sensor node, that is in the microcontroller. It will store the data, and then it will communicate. Communicate means it will send the data to the neighboring node or to the sync node. Okay. So this is going to be your how the wireless sensor network works. Okay. Then node architecture. This you have already seen in your second unit, I think so. So there are 4 main units: sensing unit, processing unit, communication unit, and power unit. And you have 5 main components of a sensor node: processor, memory, battery, transceiver, and sensor. So whenever you are thinking of a sensor node, you should think like this. This is the board that you are going to use for sensor node. Use a sensor node in the real time. Okay, even though this is given as a diagram for different diagram representing different parts, you should not consider this as the sensor node. You have to consider this as a sensor node, and there are different types of sensor nodes like this. Okay, and for every sensor node, these are the 5 different components. First one is a processor. Processor is going to be the heart of your sensor node. It will process the information that the sensor node collects. And memory, you have RAM and ROM memory. RAM memory is used for storing the data, and the ROM memory is used for storing the program code. Battery, there are 2 types of batteries: primary battery and secondary battery. Primary batteries are rechargeable, and secondary batteries are non-rechargeable. That means, primary batteries are non-rechargeable and secondary batteries are rechargeable. That means for secondary batteries, you may use some concept of energy harvesting. That means energy harvesting means you will get the energy from the solar, from the sun, wind, tidal, or vibrations. So based on that, you will be able to implement or you will be able to recharge your battery. So those are secondary batteries. One of the most important problem with wireless sensor network is energy constraint. They are not able to they are battery powered, and once the battery is over, the node is dead. It cannot communicate anymore. So most of the projects in wireless sensor network concentrate on how we can utilize the energy in an efficient manner. So battery is one of the most important component in the case of a wireless sensor network. And then you have a transceiver. Transceiver is basically an antenna which is used for sending the data from one sensor node to the another sensor node. Okay, and transceiver is having 3 different states: ideal state, listen state, and transmit state. Transmit state means it is having some data, and it wants to send the data to the neighboring node. That is called transmit state. Receive state or listen state means it is trying to listen to other sensor nodes and to get some data from the other sensor node. That is your listen state or receive state. Sleep state is the state at which the sensor node is inactive. It is not responding to anything. It is not receiving. It is not transmitting. It is just in the inactive state. Okay. So these are the 5 important components of a sensor node. So I have a small question. Okay. So how long a sensor node can work in sleep state? Anyone? I said you're having 3 different states in transceiver: transmit, receive, and idle. So how long a sensor node can live, or how long a sensor node can live when the sensor node is in sleep state?
Ma'am, until it receives a kind of a message from the neighboring sensor node, like it senses if there is anything on the network. If it's there is some message on the network, then it becomes active.
Yeah, it will become active, and if it is not, if in case your sensor node is in the sleep state for long time, or sleep state for long time, how long? That means how many years it can stay?
I have no idea,
For
ma'am.
instance, if the node is transmitting or if the node is receiving, let it be a mica node or something, any kind of node. Okay, it can, if it is in the transmitting state and if it is in the active state, a node can live only for 3 or 4 weeks. Okay, if it is no in the fully active state. If it is in the inactive state, how long or how many months it can stay? Inactive state means you are not able to receive anything. The node is not receiving anything. Node is not transmitting anything. So
Maybe
how long?
2 to 3 years, ma'am. Maybe.
Yeah, 2 to 3 years or lifelong, because it is not transmitting or not receiving anything, right? So it can live long. The node can live long. So that is why in most of the cases, if the node is not receiving or transmitting anything, we will keep the node in the sleep state. The programmers will do like that. So in order to extend the sensor node lifetime, we will do like that. When it is not receiving or transmitting anything, we will keep that in the sleep state. Okay.
Okay. Okay.
Okay. So I would like to say two things. Ask if you are doing a project in wireless sensor networks, the two important things that you have to consider is, one is the battery power. Okay, you can if the battery is dead, then you will not use the sensor node anymore. So you have to implement some methods to increase the lifetime of the battery or utilize the battery in an efficient manner. That is one thing. Second is, you can keep the sensor nodes in sleep mode whenever you are not transmitting or receiving anything. So when you are doing the programming, you have to do the program in such a way that you have to increase the lifetime of the node. Okay. So
Okay.
these are the important things. So this is the explanation of the sensor node architecture. This you can go through the slide once I share the slide with Arun sir. Okay, then you have different types of sensor nodes. Okay, Texas Instruments mode, microchip, Velos B, MSIC. So these are the different types of modes. Okay, modes or nodes. These modes are not same. Mode and node same. Anyone? You can respond. Okay, whenever I'm asking some questions, anyone can unmute and you can respond. Is mode and node same?
Ma'am, mode is a sort of embedded node, ma'am. So it has memory unit, processor, everything embedded in it.
Okay.
So node, it's a broader term. Like any kind of thing might be a node. So in normal networks, PC, NPC is a node.
Yes, yes,
So
yes.
so in
Yeah.
embedded
Yes,
networks,
very
mode
good, very good.
like that.
Yeah. But in case of sensor networks, both node and mode are same. Okay, node and mode are same. Mode is a North American word, and the node we are using as common language. In our common language, we are using node. Both in sensor networks, node and mode are going to be same. But what you said is also correct. Node, in broader terms, we can consider PC also as a node. Okay.
Okay.
So, both nodes and modes are going to be same in case of wireless sensor networks. So here we can see that there are different types of sensor nodes. Okay, different types of sensor nodes, and each of them are having different specifications. Like microcontroller, RF module is going to be the antenna used, memory, program memory, and flash memory, frequency range, data rate. All these are the different parameters given for the sensor nodes. And in this case, we can see that one sensor node is different from the other sensor node by the type of specifications, but with the difference in specification. You can see in case microchip, PIC microcontroller is used. In the Telos B, we are using Atmega microcontroller. But the main thing is that in all the sensor nodes, these are the 5 different components. Okay, we are using all these 5 components in any sensor node, but the only thing is that the specification of the sensor node is different. You have different types of microcontroller used, you have different types of RF module used. So difference between different sensor node is the difference in the specifications, and based on the difference in specification, you will be using the sensor node for different applications. Okay, so this is the diagrammatic representation of different sensor nodes. Mica mode 2, Mica 2 dot, Mica is at Telos B, WEC, Renning, and spec. So these are the different types of sensor nodes. So these are the types of sensor nodes that are available in the market. So whenever you are thinking of a sensor node, you should think like this. It's a type of board. It can be an Arduino board. It can be a Raspberry Pi. It's like a Arduino board, or it's like a Raspberry Pi board. Okay, so it's a kind of board. So you can see why there are different structures for sensor node. Why this Mica node is like this, and why this Mica 2 dot is like this.
Based on the memory capacity, processor.
Yes, based on the specifications, the different nodes are having different structures or different structure. Okay, so in case I want to find the migration pattern of a particular bird. Okay, I want to find the migration pattern of a particular bird. So I will be keeping a sensor node on the neck of the bird. So what kind of sensor I should use? What I should give the priority? Whenever I'm selecting a sensor node, what should be the highest priority given for when if I want to hang a sensor node on the neck of a bird?
Ma'am, the rigidity, the kind of environment it's going to work in, and that thing.
Everything, yes, very good. The main thing is that it should be lightweight, right? If it is very heavy, then the neck of the bird will not be able to accommodate it. So the node should be as light as possible to keep it to make it hang on the bird neck. So maybe I will be using mica 2 dot in that case. So based on the different applications, you will be using different sensor nodes. Okay. And so this is a diagrammatic representation of different sensor nodes. These are the main kind of sensor nodes. There are thousands of sensor nodes available. Okay, so this is a timeline of the sensor nodes. You can see in 1998, WEC is the sensor node that has been implemented, that has been found, and 2000 the ready node. So these are the different types of sensor nodes. And among these sensor nodes, the most widely used sensor node is the mica mode family. Okay, you can see mica, mica 2 dot, mica Z, and mica 2. So all these are mica modes family. And whenever you are doing a project in real time, that means whenever you are connecting your hardware of the wireless sensor node to the PC, you will be going to use either mica mode or telos B mode or cricket. There is another mode called cricket. Okay, there is another mode called cricket which has been found in 2004. So either you will be using mica mode, or you will be using cricket, or you will be using telos B. These are the three different modes which are widely used for real-time application. Why? Because why it has been done? Because you see, you have different types of simulation tools. Okay, these simulation tools, and there are some operating systems which has been put forward only for intended for wireless sensor networks. So these operating systems are made in such a way that it is compatible with the mica mode. So when the operating system is compatible with the mica mode, it is easier to do the project in mica mode, because when it is compatible, then you can do the project in mica mode very easily. So it is based on the type of the operating system. Operating system, if the operating system is compatible for mica mode, then you can implement the real-time implementation can be done using the mica mode. So even though there are different types of sensor nodes, if you are doing a project in wireless sensor network using the hardware component, then you can go with mica mode, or you can go with telos B, or you can go with cricket. Okay. So in your fifth unit of your wireless sensor network subject, the architecture of mica mode is given. Only the architecture of mica mode is given, because I told you the importance of mica mode, because most of the wireless operating systems are made in such a way that is compatible with mica mode. So that is why they have given more importance for mica mode in your syllabus in the fifth unit. So mica mode, I'll just rest up the things in the mica mode. You know that every mode consists of 5 main components, and you have a microcontroller used here. And this is your Atmega 103 is a microcontroller used here. And what is the purpose of microcontroller? What is the purpose of microcontroller?
It's kind of a lightweight processor. I mean, that's everything embedded in it. Like
Yeah, what is the function? What is the function of microcontroller?
Yeah, it processes the data, ma'am.
From where? From where you will get the data in?
From the sensor. From the sensor.
Is it like from the sensor only you will get the data?
Sometimes also from the antenna, like the transmitter antenna. Sometimes.
Yes, sometimes from the other nodes also you will get the data. Yes, there are 2 different ways in which the microcontroller can get the data, from the other sensor node, or from the sensor which is embedded on the microcontroller. Okay, embedded on the sensor board. Okay, so in case of architecture of mica mode, you have a microcontroller and you have a coprocessor. So what is the use of coprocessor? Coprocessor is used to handle the wireless reprogramming. Sometimes you have programmed your microcontroller, but you want to reprogram it. That means something has happened in the middle, or you want to reprogram, or you want to add more number of nodes to the sensor network. Then you have to reprogram your microcontroller. So in those cases, a coprocessor is being used, and the coprocessor used is 8-bit AVR microcontroller. And this microcontroller consists of 512 KB of program memory and 4 KB of RAM memory. RAM memory means it's going to data memory. So you can see that it's a very small program memory. It consists of only 512 KB of program memory. 512 KB means it's a very small program memory. So what is the challenge? Challenge is that when you are doing the program, you have to do the program with less number of lines. So if you are having more number of lines, then the program memory will not be able to accommodate it. So you have, when you are doing the programming, you have to do the code in such a way that you should have less number of lines. So that is why we have nowadays we are having simulators like NS3, which will do the programming in Python. So we know that if a C program with the 10 lines can be executed in 2 lines in Python. Uh, so there are simulators which use Python and other programming languages in order to reduce the number of lines so that program memory can be accommodated well. Okay, so this is and along with that you have a flash memory. Flash memory. Why there is a flash memory? What's the use of a flash memory? There is an external flash memory. You have a microcontroller. This microcontroller consists of a flash program memory and a data memory. Then why there is a extra flash memory? There's an external flash memory is present. What is the use of that?
Like a secondary memory, ma'am.
Yes, secondary memory for data or program.
Data.
Yes, very good. For data. Okay. So then you have a hardware ID. What is hardware ID? It's the ID that is given for a particular node or mode. Okay. So you know that in case of in computer networks, you could have already studied the MAC address. It is a unique address given for a device. So similarly, like that, you will be having a hardware ID that is given for the MICA mode. That is the hardware ID, and then you have a radio transceiver. Okay, radio transceiver is the antenna that has been used for sending the data, and it will be operating 916 megahertz. Okay, most of the sensor nodes will operate in 2.4 gigahertz. 2.4 gigahertz is the ISM band. It is a free license band. So most of the sensor nodes are working in 2.4 gigahertz band, but MICA mode is working in 916 megahertz. Is also license free band. And you will be able to send 40 kilobytes per second. The data rate is 40 kilobytes per second. But when as you are using hardware accelerator, you can see a small block called hardware accelerators. So when you are using hardware accelerators, you will be able to increase the data kilobits per second to 50 kilobits per second. Okay, so you will be able to send the data in 50 kilobits per second with the use of hardware accelerators. Okay, then transmission power. Transmission power is the amount of power that is required for sending the data from one sensor node to another sensor node, and which can be adjusted by using the potentiometer, by using the software. And the maximum transmission range of a MICA mode is 300 feet. Okay, you can get only 300 feet is the maximum coverage area of a sensor node. Then you can see there is a input-output expansion connector. Okay, this connector is used in order to connect your MICA mode to the PC in real time. Okay, so this particular connector is used for connecting your MICA mode. This is going to be MICA mode, and MICA mode to the PC in real time. You will be using input-output expansion connector. Okay, so this is the architecture of MICA mode. Then programming challenges. What are the programming challenges? As I already told, one is that the program memory is very small. So you have to reduce the code, the length of the code, you have to reduce to the maximum extent. Second important thing is that wireless sensor node should be capable of handling messaging, networking, event synchronization, interrupts, etc. So even if a node or if a program has to handle all these things, then the traditional programming models are not suitable. So we have to find new models to handle all these things, because your sensor node you are going to deploy in the real time environment. You are not going to do it in the always in the indoor environment. You will be going to use in the outdoor environment. So there are many factors affecting the sensor node. So all those factors has to be taken into consideration. So it is also challenging. Third important thing is algorithms are very difficult to implement. That's the same thing what I told. And the fourth important thing is you have you may be having 4 or 5 events taking place at the same time. So you should be able to, the programming language should be able to multitask. That means if you are getting 2 or more events at the same time, you should be able to respond it. The program should be capable of responding it properly. So that is respond to multiple stimuli quickly. Okay, so these are the programming challenges. Then network simulation tools. So simulation tools can be of different types. These are the major simulation tools. Apart from this, you have different types of simulation tools. In this I will be going to take NS2 and NSG for you. Okay, NS2 and NSG. I'll be going in detail because most of the projects, even the PhD projects, are doing in NS2. We are using because why we are going, why NS2 is given more importance is most of the protocols. You can have variety of protocols used in NS2, and all these protocols backend file is available in NS2. You just have to call these backend files to the front end when you are doing a program. So it is a very easy platform. At the same time, as it supports all type of protocols, it will be easy for you to implement more number of implement a bit higher projects in NS2. So I'll be giving more introduction, I will be giving practical section on NS2 and NSG, and rest all things are going to be, even I have worked with NS3, then OpNet, and TOSSIM and COOJA. All these things I have already worked with, but the only thing is that for TOSSIM and COOJA, you need the sensor node. Okay, you need the hardware sensor node you need, and rest all things are going to be implemented in simulation. Okay, you are not having a hardware part in this. You cannot connect your hardware to the PC and you can simulate. You cannot simulate using all these things. If you want to connect your hardware to the PC and if you want to see the simulation how it is working, then you have to go with either TOSSIM or COOJA. Okay, rest all gives only the simulation part. That means software platform only it is supporting. Okay. So these all things, I think you can go with all these things when I share the slide because.
In one of the previous seminars, so actually we were taught about TinyOS, ma'am.
Yes, I'll say what is TinyOS.
No, ma'am. But TinyOS is the one which is mostly preferred, ma'am, because so is NS2 compatible with TinyOS? That's my question, ma'am.
NS2 and TinyOS both are different. Okay, TinyOS, what you're telling is it's an operating system. I am telling about network simulation tools. Simulation tools means it's an application that works on the operating system.
Actually, what I'm asking is, can we use NS2 for stimulating events in TinyOS? Because TinyOS.
No, you cannot.
Okay.
You cannot use because if you are using TinyOS as the operating system, you have to use a simulator as TOSSIM. This is a TinyOS simulator. Okay. So if you are using TinyOS as the operating system, then you have to use TOSSIM. And at the same time, if you are using CONTIKIOS, there is another OS called CONTIKIOS. So if you are using CONTIKIOS, then the operating system, simulation you will be using will be COOJA. COOJA is a simulation tool you will be using.
Okay.
This NS2, NSG, NS3, and all these things you will be able to implement on Windows as well as in Linux platform. But only thing is that it is not going to provide you the real-time implementation. You can do the simulation. That's all. You can see how it is working in the software. But if you want the real-time implementation, you have to either go with TOSSIM or COOJA.
Okay, man. Thanks.
Okay. Yeah, thank you. So these things you can go with. Okay, I'll just send the, because if I'm taking all these things, then I don't think you will get the time for. I will not get time to touch up NS2 and NSG. So at least I have to give you the basics of NS2 and NSG so that you can explore and you can do the projects in those two platforms. Okay, so this is the difference between different OS. The only thing that the one who have asked now. Okay, so you can see that WSN platforms, it is not available in NS2. Okay, WSN platform means you cannot do the real-time implementation in NS2, and OpNet, it is not available. TOSSIM, you can do WSN platform, you can do using TOSSIM by using the Mica mode. Okay, Mica mode is a sensor node used.
I actually asked the question because in the previous sessions we were told that TinyOS is the one which is preferred for embedded systems because it can you need not go out there and program the TinyOS. So that's why I asked if with TinyOS can we use NS2?
No, you cannot use TinyOS. You cannot use NS2.
Got it.
Yes. Okay. So then COOJA, again, some types of modes are using, and that means if you are using TOSSIM, that means you will be using the operating system as TinyOS, and above that you will be installing TOSSIM as a simulation tool, and then you will be connecting your Mica mode. Mica mode you will be connecting to your computer so that you will be able to see how the sensor node respond to it.
Okay.
But in NS2 and all, it is not providing hardware support. It will support only the software. You cannot, if you
Okay.
connect the hardware also, it will not be able to detect it.
Okay, ma'am.
Okay, yes. So these are the different operating systems: TinyOS, CONTIKIOS, MANET, BTNet, Source, and NanoRK. And in this, the most
Madam, 1
wide,
minute, Susan, madam. Actually, they are familiar with MATLAB. Okay, I can suggest to understand what is NS2 and TinyOS. So that I think in MATLAB we can simulate all the algorithms, but real time it is not applicable. So
yes, sir.
when we need real time, obviously we have to use TMS kit
Yes,
for
yes, sir.
implementation purpose.
Yes, sir.
Okay. So like that in wireless sensor network also, NS2 is purely applicable for simulation purpose. If it is successful, then we can move real time.
Yes, sir.
Yes. Okay. Arsha, are you
Yes,
able to
sir.
understand?
Yes, sir. Got it. So
Yeah,
like,
okay,
we
okay.
don't use
Yeah, yeah.
hardware in MS2. We just do it in the
Yes, yes.
program. Yeah.
Correct,
Yes.
correct.
Got it. Got it.
Okay.
Can
Okay,
I?
madam.
Okay,
Yeah, you
okay. So WSN operating systems. So these are the two different operating systems which are widely used, even though there are many operating systems, TinyOS and Contiki, that I have already explained to you. So these are the two operating systems used. And WSN developing platforms. Developing platform means which are the companies that are developing wireless sensor nodes. Okay, Crossbow is the most widely used company, or widely not widely used, most about manufacturing company of wireless sensor node. And the rest, Dust Networks, Sensoria Corporation, Ember Corporation, WorldSense, all these companies are manufacturing wireless sensor nodes. Okay, and whenever you are doing so you have already familiar with the sensor node, right? These are the different sensor nodes. You cannot connect the sensor node directly to the computer. Okay, for that you need a programming board. Okay, on the program, so the most widely used programming boards are MTS 310, MTS 400, MIB 520. So if you want to go with the data sheet of this, so there is a link given below. You can go with that and you can refer that. And so this programming board is MIB 520. Okay, this is a programming board, and in that you can see which I'm showing you in the using the pointer. This part is going to be mica 2 dot. So you will be placing the mica 2 dot inside this programming board. Is it clear for you? This is not the sensor node. Okay, this is not the sensor node. This is a programming node, programming board. On the programming board, you are going to place the sensor node. Okay, mica 2 dot you have already seen. This is a round structure. Mica 2 dot I have already shown the diagram. Mica 2 dot is like this. So this diagram, this round type sensor node, you will be placing on the programming mode. Okay, programming mode, you will be keeping it. So this is a space for mica 2 dot, and this is a space for mica 2 interface. Mica 2 interface means there is another another mica mode 2. Okay, this you will be able to place on the top of this. So this is how how you will be able to connect your programming board to the computer. So this is a serial interface to the laptop. Okay, so you will be using a programming board. On the top of the programming board, you will be using some sensor nodes which is compatible for that board, and then using the serial interface, you will be connecting that to the laptop. Okay, and this is the hardware setup. Okay, so you have the laptop, you have a serial cable, and this green color is going to be your programming board. And on the top of the programming board, you can see a sensor node. Okay, this is a sensor node, and this elongated thing is going to be the antenna. And from the sensor node, you can see a battery going. Okay, it is 2AA battery. Four batteries you are using. This is a symbol. It's a battery. Is the general battery that you are using in your clock. Or okay, so you can connect that to the battery, and in this way you will be able to see the simulation on your laptop. Okay, so this is a hardware setup of how you will be able to connect a sensor node to a computer. Is that clear for you?
Yes, ma'am.
Any doubt in this? Because I'm going, because already half an hour is over, and I'll just go with the simulation part. So that's why if you are having any doubt in this hardware setup or up to what I have taken, you can ask the questions now. And after that, I'll go with the NS2 and NSG implementation, because I have to show you how the program is running, and how the simulation, how the simulation is being carried out, how you are going to find the parameters like throughput, delay, and all, how you are going to find in the sensor node. So those things I will show you. So before that, if you're having any doubts, you can ask up to this.
Yeah, any doubts from the student side?
Clear with me, sir.
Okay, actually this session it will end only by 12:30. Okay, so half an hour extra for today's class. So the madam availability also very less. So that's why we are allotted additional half an hour for madam to complete your 50 minute. Okay, so utilize this opportunity and learn many things from her. Okay.
So can I go with the NS2 and NSG?
You can start, madam.
Okay, okay, sir. So programming using NS2 and NSG, I have been using a Linux platform. Okay, so NS2 stands for Network Simulator version 2. And as I already told, why this NS2 is widely been used is it is able to support more number of protocols like TCP, UDP. What is TCP and UDP? What kind of protocol is that? In which layer TCP and UDP works?
Transport layer.
Yes. Okay. What is FTP and HTTP and all? In which layer FTP and HTTP works?
Application layer protocol.
Yes, very good. What is DSR? You have DSR, DSDV, AODV protocols. What are those protocols?
No idea, man.
Okay. AODV, DSDV, I think you have studied in your third unit or fourth, I don't know, in which unit you have routing, on that in that unit you have already studied AODV and DSDV. So these are the
Yes,
routing
madam.
protocols.
It is there.
Harsha remembers last SIMS, but not this SIMS, right?
Yes, madam.
This one.
So this AODV protocol we are already taught in second unit, I think.
Okay, sir. Okay.
Routing protocols.
Oh, yes, yes. Those are routing protocols. Okay, so
First unit. Okay.
how many layers are there in your OSI model? How many layers are there in your OSI model?
6, man. 6.
OSI model consists of 7 layers. Okay, it consists of 7 layers. Yes. Okay, you have 7 layers, and all those 7 layers are available in wireless sensor network also. Okay, computer network, the hierarchy goes like this: computer networks, wireless sensor networks. All those are going to have the same basic idea, basic things. Okay, so 7 layers you are having in computer networks means 7 layers you are having in wireless network as well as wireless sensor network also. Okay, so that is why we are using same protocols. TCP and UDP are using as transport protocol in computer networks. Same protocol you are using in wireless sensor networks also. All these protocols are using in computer networks. Same thing you can use for your wireless sensor networks also. Okay, and in NS2, the scripting language uses TCL scripting. Okay, this language is what that I'm going to teach you. Okay, with limited time, I'll teach you, and you can go and explore from the websites about the different programs. Okay, I'll show you a small program. I'll explain small program, then you can explore it. Okay, so you can download your NS2 in this from this website. Okay, isi.edu nsnam ns. So from this website you will be able to download your NS2. So installation of NS2 takes almost 1 hour. So I'm not showing you how to install NS2. If you have any difficulty in installing NS2, I'll share my phone number and or my mail ID, so you can contact me. Okay, because installation takes another 1 hour, so I'm not going to show the installation. Instead, I'll show how the program works. Okay, and the operating system used for installing NS2, you can work in both Windows and Linux. Okay, if you are using Windows, you have to install a software called Sigwin software. Okay, you have to install a software called Sigwin software. This Sigwin software acts as a Linux platform for Windows. Okay, it provides a Linux platform for Windows, and on the top of your Sigwin, you will be able to install your NS2. And if you are using Linux OS, what are the different types of Linux OS? You have Ubuntu, you have Fedora, you have Red Hat. Different types of Linux OS are there. Okay, if you are having Linux OS, then you can directly install your NS2. So I'm showing the installation of NS2 in. I have installed NS2 in Linux, because I found many difficulties with Windows and processing speed has been reduced. So I'm not using Windows, I'm using Linux. Okay, so I'll show you how to install, how to program, or how to do the programming in Linux. NS2 implementation, as I already told, you will be using a script called a TCL script. Okay, this script I will teach you now. And then you have the backend program. You have different protocols like FTP, UDP, TCP, and DSDV, AODV. All these protocols are there, right? And you don't have to program all these protocols. All these codes are available on the backend of your NS2, and these protocols are implemented in C++ language. Okay, so all these protocols are already implemented in your, whenever you are installing NS2, these programs will automatically come along with that. Okay, this package will come along with that. So you just, whenever you are calling calling these functions or DSDV or AODV, when you are calling in the front end, it will automatically go and get the data from the backend. So you have to concentrate only on the TCL script, and whatever you are using in the TCL script. So if you are calling DSDV in your TCL script, ask the programming, ask the C++ language is already available in your backend. It will just take it. You don't have to program it. Okay. So the main thing what I would like to say is you are concentrating more on your TCL script, and with the TCL script you will be able to know how the simulation works. This is the node. Okay. At the simulation scenario is the output. This is the program that you are going to do, and this is the output. 1, 2. This is the output. Okay. This is 2 nodes. You have created 2 nodes and a link between 2 nodes. That is the program here. Okay. So even whenever I'm telling there's a node, you have to understand the hardware architecture of the node. It consists of 5 main components. Even though it is a round shape, it consists of 5 main components: microcontroller, power supply, memory, transceiver, everything is present. Okay. So these are the NS2 components, and here you are having NS2 as a simulator. NAM is the network animation window. This is the window in which you will be able to see the output. When you do the program, after you execute the program, you will be able to see how the nodes work. That will be shown in the animator window. That animator window is called NAM window, and NAM editor is the editor or the window in which you are typing the TCL script. Okay. And the pre-processing and post-processing. Pre-processing means you will write the TCL script, you will run the program, you will be able to see how the nodes are working or how the nodes are sending the information from one node to another node. That you will be able to see. That is pre-processing. Post-processing means once you do a program, once you run a program in NS2, two files will be created. Okay, one is trace file and one is NAM file. Trace and NAM, .tr and .nam, .nam. So these 2 files will be automatically generated based on the program that you have written. So NAM is used for seeing how the working of, used to see how the sensor node works based on your program. And with the use of trace file, you will be able to analyze what is the bandwidth, what is the delay, how much is the throughput, how much is the energy being consumed. So all those type of numerical values you will be able to do after the program is executed. That is called post-processing. Okay. Pre-processing is just you are writing the program and running the code, and you will get an animation window, how the sensor node is working. You will be able to analyze. And post-processing means after running the program, 2 files will be generated. One is your trace file and second is your NAM file. So with these 2 files, how you are able to calculate the bandwidth, delay, throughput, energy of the sensor node. So those things will come under your post-processing. Okay, so simple program in NS2 using 2 nodes. See, at any point you can ask doubt, okay, because I'm going to start the programming, and if you are having any doubts in programming, you can ask, and I will tell what are the tricks you can use inside this whenever you are programming of your own, okay. So this is the initial step. I'm going to implement a 2-node topology, okay. I'm going to implement 2 nodes in wireless network, in 2 nodes connected wirelessly. Okay. So first one is set val chan. Val chan means set the value of the channel. Value, VAL means value, chan means channel. Set the value of the channel. What is the channel you are going to use? You can either use wired channel or wireless channel. So here I'm going to connect 2 nodes wirelessly. So it is going to be the wireless channel. Okay, I'm using wireless channel. And what set value of propagation? What is the propagation you are going to use? You have different types of propagation: free space propagation, two-ray ground propagation, Friis model propagation. Different types of propagations are there, but most of the cases in NS2 we are using 2-ray ground propagation. So here I have represented this as 2-ray ground propagation. And third is set the value of network interface type. Network
Ma'am,
yes.
just a moment. The red thing which you have highlighted, the complete thing is the command name, or is the set val channel is only the command?
The complete thing is the command.
So
Okay.
channel slash okay.
The complete thing is the whole red. What I have written in red is going to be a program. Okay, and the right side I have written in black color, which is going to be the explanation of that particular uh, line. Okay, particular line or command. Okay, so this is optional. You can or you don't have to you don't have to use this in your program. This is not needed. Okay, the red color is not needed. And the another important thing is you can see set value, chant, set. You can see all these things, right? This right side part is going to be same for all the sensor nodes. Okay, this left side part is going to be changed based on your application.
Okay.
So set value network interface. So wireless physical interface is being used here. Set the value of MAC. MAC is medium access control protocol. What's the type of MAC protocol being used? 802.11. What is 802.11? What is IEEE 802.11 standard?
ISO standard, ma'am. It's
wireless LAN. It's a
Ethernet.
IEEE 802.11, yes, Ethernet, yes, correct. It's a wireless LAN standard. Okay, 802.11 is going to be a wireless LAN standard. And if it is 802.15, what is that?
Is it Wi-Fi, ma'am?
It's Wi-Fi and okay, Wi-Fi again you'll be using 802.11. Okay, Bluetooth you will be using 802.15, 1.5. Okay. So if you are using Bluetooth in your program, you can replace it as 802.15, 802_50. Even though 802.15 point I'm telling, in program you have to write it underscore 802_15. Okay.
Ma'am, and another doubt, ma'am. So in the mica mode, you told that the frequency is 916 megahertz, ma'am.
Yes.
But Bluetooth uses 2.4, ma'am. So 2.4 GHz. Then how?
Yes. See, here you are doing something right. Here you are giving some specifications. It should be based on some sensor node. You can take a mica mode. Okay, you can take a mica, see the specifications of that mica mode. Then from the specifications of the mica mode, you have to give the specifications here.
Okay.
You cannot give it simply. You have to take a sensor node. You have to study about sensor node. You have to take the data sheet of the sensor node, study the sensor node, what is actually it is doing, or what type of MAC it is using, or what kind of wireless topology it is using. So all those things you have to study. Then you can give the you can give the specifications here. Okay, you cannot give it simply.
Okay, ma'am.
Okay. So interface queue type is you can use drop tail or priority queue. This you have already studied in your computer networks, I think so. Drop tail means consider that a sensor node is having a buffer size of 100. Okay, buffer size is 100. That means it is able to accommodate 100 packets. Okay, it is able to accommodate, or it is able to store 100 packets. And you are sending 150 packets. From the another node, you are sending 150 packets. And this node is capable of accepting only 100 packets. What will happen is the rest 50 nodes will be dropped down. Okay, that first in first out. It will come as first in first out. Which packet is coming first, it will be accepted, and once the buffer is full, it will get dropped down. That is drop tail. Priority queue means you have the sensor node is capable of accepting 100 packets, and you are sending 150 packets. Based on in that 150 packets, you will be having a filtering based on the priority. In that 150 packets, which are the highest priority packets, that 100 priority packets will be sent to the sensor node. That is priority queue. So in this way, you will be able to use different types of queues. And then is link layer. LL means link layer. Link layer means in your data link layer. Data link layer is divided into two. That is link layer and MAC layer. Okay, link layer and MAC layer. Link layer will do the function of error control, flow control, and all. So this is the link layer function. So this is not as LL. And what is the type of antenna used? Antenna used is omnidirectional antenna. And queue length. This is what I told. Your sensor node is capable of if the sensor node is capable of accepting 50 nodes, it's a buffer size. Buffer size is 50 nodes. You can give us 50, or you can give us 100 as per your need. You can keep the length as per your wish. Okay, and here NN is the number of nodes. Number of nodes is I'm going to implement 2 nodes, so it is 2. You can implement 50 nodes. If you can keep it as 50. What is the routing protocol used? Set value of RP. RP means routing protocol. Here I have taken AODV protocol. You can take DSDV protocol, DSR protocol, any protocol you can take. which is having the backend file, you can take that. If you are taking a new routing protocol, like if you are going to implement a new routing protocol, then if the backend file is not present in NS2, then you have to program AODV. Okay, then you have to program the routing protocol. Okay, if you are that means if you are introducing a new routing protocol which is not available in the backend file of NS2, then you have to write the code for C++. You have to write the program in C++, then you have to call the program. Okay, this routing protocol is already available as a backend file in NS2. So I am just calling AODV so that it will take the data from the backend file and it will work accordingly. Then set value of x, value of y. Value of x is given 798, and I will show you what is value of x and value of y. Yeah, next slide I will show you. Okay, this is your NAM animation window. I said no. After running the program, you will get an animation window which shows how your sensor node is working. This is just a snapshot of a NAM window. So this size, this space is going to be your NAM window, and this is your x-axis. How much is the x-axis and how much is the y-axis? So this is the x and y-axis shown here. Value of x 798, value of y 500. You can give it as 500, 500. You can give 500, 600. As per your wish, you can give. Okay. Set value stop. That means at what time your simulation stops. It is at 10 milliseconds. Okay. So in the first step, what I try to say is your left side things are going to be same and the right side things are going to be changing as per your need. You can change it. So next is net set
and can be different, ma'am.
Yes.
Order can be different, ma'am.
Yes, order can be different. Order can be different. No problem. Okay. Next is set ns new simulator. So in C and all, you will be having hash include std.h header files. So similarly, this can be considered as a header file, or whenever you are starting an event, you can use this as the command set ns new simulator. Then set up topology. Topology means the geographical area. This is going to be a geographical area. Okay, as per NS2, this is going to be a geographical area. So set topology, new topology. This is going to be, these things are not going to change. Okay, these are the default syntax for creating any program. These are going to be the same syntax for any program. Okay, so topology means what is the topology, what is the geographical location, geographical area that you want to do, that you want to simulate your program. So here flat grid topology. What is flat grid? Why it is flat grid? Flat grid means it's a two-dimensional topology, because we cannot show this simulation in three-dimensional. We can show only in two dimensions, so that is called flat grid. And here you can see one thing, $. Okay, here you can see one thing, $value of x. Whenever you are using $, that means that that particular command is already been called before. Value of x we have already indicated before. Value of x is what? 798 is the value of x. Okay, so we are just calling that value here. Whenever you are having a $, that means that particular command or value of x or whatever that comes after $, it is already been set somewhere. Okay, the value is already been set. If you are not doing this, $value of x, you are not doing this, then you have to write here as 798. You can write here as 798. Okay, if you are not calling like this, you can straight away give the value of 798. Okay, then GOD is a general operations director, and this particular variable is used for storing how many nodes you are going to do in your program. Okay, it will store the number of nodes, and okay. So as I already told, whenever you are running a program, you will be having two files. One is a trace file and second is a NAM file. This is the syntax for trace file. Set trace file open wireless.tr. This green color what I have shown, this is going to be the file name of your trace file. You can give any name. This wireless you can change, and you can give out.tr. You can give your name.tr. Anything you can change. Okay. So whenever you are implementing a program and whenever you are running a program, two files will be created. One is a trace file and second is a NAM file. And the syntax for NAM file and trace file are going to be same. Okay, whatever I have written in the red color is going to be same for all the programs. Whatever I have changed in the green color, that is what you have to change. You can change to this is the file name for your NAM trace file. This is the NS trace file, and this is the file name for your NAM file. Okay, rest all is going to be same. Then this is where you are configuring your node, your sensor node. You are configuring what type of routing protocol you are using. $value of RP. You can see dollar. Dollar means you have set this value somewhere. Where you have set? You have set that in the first. Initially, you have set this value of RP is AODV. Okay, value of RP is set as AODV here. So that yes.
In the trace file and NAM file, there are some more commands. No, ma'am. What are those? NS trace, all those and all. Yeah, that one. Ma'am.
Yes, okay. NS trace all means you are writing a program from the first line to last line. When you are running a program, it will trace each and every event. It will trace. Maybe if you are having 5 nodes, node 1, 2, 3, 4, 5, you are sending at 0.1 seconds. You will be sending the data from node 0 to node 1. It will trace it. So and it will make a trace file. I show you the trace file. Okay, it will be more easy for you. This is going to be a trace file. This is a trace file. At time 1.355. It will trace the data based on your program. You may have given the program like node 0 to node 1 at a time 0.1 seconds. You will be sending the data. So it will trace all these things. What are the events that is happening when you are running a program? All those will be traced. Okay, this is a trace. I'll explain this. Okay.
Okay.
So these are the trace files, and NAM trace means. And when you are running the program, it will trace if node 0 and node 1 is transmitting the data. You may be given as a command, but if you want to see that in animation, then it has to trace. That is a NAM trace used. NAM trace is used for tracing tracing your program and showing that traced file in the form of an animation. Okay. You will be more clear with this once when I show at least one animation. When I show one animation, you will be able to see. You will be able to clear the doubts. Okay. So these are the node configurations. This we have already introduced. Okay, all these types: antenna type, propagation type, physical type, channel. All these things we have already introduced in the first step. Okay. So it is just whenever you are using a dollar symbol, that means that you have already set the value, and that value will be called over here. Okay. Here. Okay, so this is the node configuration, and this is going to be same for all the program. Okay, and next is your node definition. I have to create 2 nodes. Okay, node 0 and node 1. So how I have to create the node? Set n node, ns node, x-axis of the node, y-axis of the node, z-axis of the node. Okay, and initial node position n node 30. So initial node position I have given this as the initial node position at 4 node 2 297. That means this is going to be your x-axis and y-axis. This is x-axis, this is y-axis. So if you are fixing a node here, that means it is having a x value, y value, and z value. Z value is always 0. Why z value is always 0? Because we are using 2D. We are not using 3D. So that is why z is always 0. And this 30 shows the size of the node. Okay, if it is keeping as 10, then size of the node will be small. Okay, for these all things you are going to use for to make the animation more attractive. You will be using these things. Okay, and node 1 is going to be your okay. You are giving set x value, y value, and z value. Again, the position of the node is given as 30. 30 means the size of the node. 30 here denotes the size of the node. So in this way, you will be able to create nodes. Okay. Next is that see, this is a wireless node. Okay, so there is no need of doing any connection between node 0 to node 1. In case if you want to do a connection between node 1 to node 2, you can create simplex node, or you can create duplex link. Okay, so this is the syntax for creating this is a syntax for creating a duplex link. Set duplex link n node to n1. So from n node to n1 you want a duplex link, and 1 MB is the bandwidth, 5 milliseconds is the delay, and the type is drop tape. So this 1 MB and 5 milliseconds you can change as per your wish. Okay, so that will be done only in the case of wired network. In wireless, you don't need the duplex link or simplex link. You don't need it. Then next is you have to add the TCP connection. Without TCP connection, you will not be able to send the data. Transport protocol you need for sending the data. So for source agent, you can use UDP or TCP. Destination agent will be null or TCP sync. Load monitor we are not using in most of the programs. you'll be using null and TCP sync. Okay. So if your source agent is UDP, you will be using the destination agent as null. And if you are using TCP, your destination agent will be TCP sync. Okay. So here I have shown you, here I have shown you two nodes, N node and N1. And node 1 TCP0 is attached. That means it's a source node. Source agent is TCP. Okay. At the same time, your destination agent is going to be null or TCP sync. So TCP, if I'm using, means TCP sync is the destination agent, and if I'm using UDP, destination agent will be null. So TCP I'm using as the source agent, and sync one, sync TCP sync is going to be the sync node. Okay, we are not using null here. So here you can see set TCP0. TCP, you are giving the number for TCP. If you are not giving the number also, in this case it's not a problem. Okay, because you are having only one source. If you are having more number of source, then TCP0, TCP1, TCP2, it goes like that. So whatever I have given in the green color, it is the thing that you are going to change. Rest all is going to be your syntax. Set TCP0, new agent TCP. Okay, so TCP is used here whenever you are using TCP, and your next line is NS attached agent, N node TCP0. N node is attached to TCP0. Okay, next is your sync. So sync 1. Sync 1 is TCP sync. As I already told, if you are using TCP, you have to use the TCP sync. So sync 1, TCP sync, and you have to attach your node N1 to sync 1. Node N1 to sync 1. Okay. Then you have to connect your TCP0 to sync 1. So NS connect TCP0 to sync 1. That means that you have created a connection between your node 0 and node 1. So you have created a TCP connection between your node 0 and node 1. And the packet size is 1500. You can give the packet sizes anything. Okay, 2500 or 1500, anything you can give. Now what you have done, you have created the nodes and you have created the transport protocol for sending the data. Then where is your data? You need the data. Okay, so in order to create traffic, you have two different protocols. One is CBR and second is FTP, file transfer protocol or constant bit rate. If you are using UDP, then you have to use CBR as the application, that means traffic, and in case if you are using TCP, you have to use FTP. We have used TCP as our agent, and so the traffic we are using is FTP set. So TCP0 is connected to FTP0. So set FTP0, and here we have used TCP. So here FTP you are using means FTP. The attach agent TCP0. You have to attach your FTP to TCP. And at what time you want to send the data? You want to send the data at 0.5 seconds. And at what time you want to stop the data? You want to stop the data at 10 seconds, 10 milliseconds. Okay. So this is how you have to connect your one node with the another node. Okay. So once you have created the sensor node, after that you have to create the transport protocol. And if it is a TCP, you have to use TCP sync. And if it is a UDP, you have to use UDP null. And if it is UDP, you have to use CBR as the application. And if it is TCP, you have to use FTP as the application. So here you are using FTP. For what is the purpose of FTP? FTP is, in general term, you can say that FTP is used for creating a dummy packet. You want to send the packet from one node to another node. This is just creating a dummy packet. Okay. This is how the traffic is being carried out in NS2. So here I have shown only two nodes. Okay, if you are having another node, N3 is again acting as a source node, means you have to give TCP1 to that node. Again, you have to implement, you have to give the connection like this. The same things will be repeated there. Okay. And this is your final finishing statements. You can see what all things you have opened. You have opened your trace file. You have opened your trace file. You have opened your NAM file here. So you are going to close all those things. Trace file is getting closed, NAM file is getting closed, and now you are going to execute the program. This is the program that you are going to execute. And NS run, that is the final step. Okay, so this is how the programming is being carried out. So I don't think you have understand it fully, because NS2 usually when I take the class, I will take for 1 day. Okay, these things I'll take for 1 day. As the time is limited, I'm not able to concentrate on a particular line for more than 1 minute or 2 minutes. So if you are having any doubts, you can contact me, okay? Because as time is limited, I'm not able to do the, I'm not able to drag it. Okay. So this is how the programming is carried out in NS2. And now I'll show how this programming is done in NS2. Okay. So what, as I already told, I'm not using Windows. I'm using Linux OS. So for installing the Linux OS, I have used a software called VMware Workstation. Okay, VMware Workstation. This you can download freely from your net. VMware Workstation. This workstation will provide you can install operating system on your VMware. Okay, and here I have installed Ubuntu already. So if you have any difficulty in installing Ubuntu here, see, whenever if you want to install Ubuntu, what you have to do is you have to file new virtual machine. Okay, you can go to nest, and here you can browse the file, ISO file, Ubuntu ISO file. You can browse. You can give nest and go on. At the end, you will be able to install the Ubuntu, and you will be able to see Ubuntu here. Okay, you have only thing is that you need the ISO file of your Ubuntu. Okay, as I have already implemented or as I have already installed Ubuntu, I'm just clicking on Ubuntu, and then you have to click at power on this virtual machine. Okay, so VMware is a software on which you can install your Ubuntu or any Linux OS. You will be able to install, and on the Ubuntu, I will be installing the NS2. Okay, I'm not going to show how to install NS2. Instead, I'll show how the program is running in NS2. As I already told, NS2 installation takes 1 hour, almost 1 hour. If you're having a good network connection, it will take 45 minutes or 30 minutes. You'll be able to complete, but mostly it will take 1 hour. See, these things, I'm sure that you won't be able to understand it fully, but I just tried in such a way that you will be able to use this particular software in your final year project. Okay, so this is the Ubuntu front page. I'll make it as a full screen. Okay, so this is your Ubuntu. You may have already seen the Ubuntu front page. Okay, so I'll just see. I have shown you one program, right? In your PPT, I have shown one program. Okay, that program I have copied in this particular file, wireless one. Okay, in this I have already. So as I already told, when you are running your TCL file, this is a TCL file. Okay, you are always writing your data in TCL file. Whenever you are giving the name for the file, you have to write .tcl. Whatever be the file name, you can give any file name. Okay, you can give any name. Let it be tt.tcl. .tcl should be there as the extension. Okay, else it will not read the program. And whenever you run the program, these two files will be automatically generated: .nam file, .tr file. I'm going to delete these two files. Okay, I'm going to move to trash. Now these files are not present. So after I run the program, you will be able to see these two files here. I'll show you that. Okay. So whenever you want to run the program, you have to click at Control Alt T. Okay, Control Alt T. Terminal window will get open. Control Alt T. Okay, simultaneously at the same time you have to click at Control Alt T. Okay, and this is your home. Okay, this is whatever is coming here. It is going to be your home. But where is your wireless one .tcl present? It is present in desktop, RMK programs, wireless one. So you have to go to this location. If you want to go to this location, you have to write CD. What is the location? Desktop. DE desktop. So desktop. Then you have RMK programs, RMK programs. Then wireless. So this is the wireless one. Okay, so this is the location. So now you can see you are inside desktop, you are inside RMK programs, you are inside wireless one. Okay, and if you want to see some what is there inside your wireless one, you can give ls. You can see wireless one.tcl. The program is there. Okay, so if you want to run the program, the only command used is ns, the file name, wireless.tcl. Okay, so you can see some windows has been pop up. I'll show you. Before that, you can see what is the thing that I have that is pop up after the command. Number of nodes is set as 2, and at the end you can see the sorting list done. If it is done, that means that your program has been executed successfully. If there is some errors, the error will be displayed over here. Okay, in the same place the error will be displayed, and you have to correct the error. Okay, this is the animation window. You can run the program. See, you can increase the time. Okay, if you want to make it more. So yeah, You can see this, right? So 0 to 1, a transmission is going on. As it's a wireless transmission, you can see the round is going on. That this round denotes the coverage area of the sensor node. Okay, so the data is transmitting from 0 to 1. At the same time, you can see a small packet going back from 1 to 0. Okay, if you keenly see, you can see this is a small packet, and this is going to be the acknowledgement packet. Okay, this is going to be acknowledgement packet because you know that in case of TCP, you will be having an acknowledgement packet. So this is how the simulation is being carried out. Okay. So I have given a very small program, creation of 2 nodes and sending the data from 0 to 1. This is the program. Okay, this is a program we have done in the PPT, same program. Okay, so this is the end of your simulation. At time 10 milliseconds, we have set the stop time as 10 milliseconds. So at time 10 milliseconds, your program will get stopped. Okay, and I'll show you one thing. That is wireless1.tcl. I have already deleted these 2 programs. These 2 files I have already deleted. But when I run the program, these 2 files came. Okay, that means whenever you are running a TCL program, the 2 files will be automatically generated. That is your .tr file and .nam file. Okay, and wireless1.tcl, as I already told, this file contains the same program as what I have shown in your PPT. Okay, same wireless set, wireless scan, wireless propagation, same thing. NS simulator, topology, NAM trace file, NAM file, then creation of your creation of your sensor nodes, sensor node creation, agent creation, then your application, then your FTP creation, and finally the termination statements. The same thing which I have shown in your PPT, I have just copy paste over here and I have run the program. Okay, this is how the program you will be able to run in NS2. Okay, and if you're too lazy in,
I mean, Windows also can we do the same thing, ma'am? Like in a notepad, write the program, save it in this, and use the ns command in the terminal window and try to get the output. Will it work, ma'am, in Windows?
No, it will not work.
Okay,
it will not work.
Okay, ma'am.
So that is all about your NS2. Okay, in NS2, you are writing the program. Okay, you are writing the program and you are getting the output. Now I'll show you, if you're too lazy in writing the program, I'll show you a small technique, okay, or another important thing. That is,
Madam, I think Arsha asking different question, whether this NS2 working under the platform of Linux only, or it will support in Windows also.
It will work in Windows also, sir. But the thing is, in Windows, you have to install you install a software called Cygwin software. That Cygwin will act as a Linux platform.
Okay, okay.
And on that Cygwin, you will be able to install NS2 and you can do the program like this.
Okay. So then you are suggesting if it is Linux, it will be comfortable.
The thing is that when I use in Windows, my processing speed got reduced and it's getting hanged frequently. So that's why I have shifted to Linux.
Okay, madam. Okay.
So the next software is your nesG. Okay, if you are in nesG, you don't have to program anything. Okay, I'll just show you how to. nesG 2.1 is the software, and this software you will be able to install. Sorry, you will be able to download from your net. This is also free software. Okay, nesG means network simulated. Sorry, NS2 scenario generator. Okay, NS2 scenario generator. So again, I'm going to Control Alt T. And where is my nesG present? Okay, in downloads, I have done nesG 2.1. Okay, nesG 2.1. So what I have to do is the command for executing nesG 2.1 is Java -jar nesg 2.1.jar. Okay, jar. Okay, so if you run this, I have to go to downloads. Okay, cd downloads, and then I can run this command. So this is your nesG generator. Okay, here you are not going to do any programs. If you are too lazy in doing programs, then you can go with this platform. Scenario. If you want a wired scenario, then you can go with that. Wireless means wireless, you can go. Okay, I'll go with wireless. Okay, this is a platform. So you can see node. Okay, node. You have vertical chain, horizontal chain, grid, or random. You can do any one you can select. Okay, vertical chain means how many nodes you want. You want, let it be 3 nodes. If it is 3 nodes, click on this. The 3 nodes will be generated. Okay, these 3 nodes will be generated. You don't have to create the nodes. I'll show you how it is getting executed. Wireless scenario. And again, the same program I will show you. Okay, node 0 and node 1. Okay, 2 nodes I'm going to create. So 2 nodes are created. This is not wireless. Sorry, this is not wired. Okay, this blue line does not represent that is wired. If it is this is wireless. If it is wired, then arrow mark will be there. Okay, this is wireless. Okay, and then you have to create the agent. What is the agent? If you are using TCP, you can keep it as TCP, and if you want to use UDP, you can use UDP also. And if I'm using TCP as the source agent, then my destination agent will be TCP sync. Okay, so I will be just keeping TCP sync. And now I want to connect TCP 0 to sync 0. Okay, I have created the connection between TCP 0 to sync 1 so that it will be able to communicate between node 0 and node 1. Now what I have to do? I have to create the dummy packet. Dummy packet will be created by using the application software FTP or CBR. So when, as I already told, if you're using TCP, you have to use FTP, and if you're using UDP, you can use CBR. So, so FTP I have created. Okay, whenever you are creating FTP, you have to give the start time and stop time. Start time I'm giving it as 0.1. Okay, and stop time I'm giving it as 10. Okay, so that's all. You don't have to program it. This is the same thing what we have done in the program previously. And parameters you are having. As I already told, whenever you are running the program, you will be having a trace file and a num file. So trace file, you can change the name. Okay, you can change the name nsg .tr, and this I am changing it as nsg.nav. If it is not changing also, no problem. Okay, and then wireless. See, we have seen all these type of parameters. Channel type is a wireless channel, and propagation model is 2-ray model, and physical type is wireless physical, and the protocol uses IEEE 802.11. So these things we have already seen. Routing protocol is DSDV, it is given. But what we have done is we are done in AODV. Any protocol you can use. So this is a wireless setup. So I'm just closing it, and TCL. We can see TCL here. Okay. If I'm clicking at TCL, automatically the code will be generated. You can see the code is generated. Previously we have written the code. Okay, so in this case, if we are implementing like this, the code is automatically generated. Same code, the same thing we have given here, and NS simulator, topology creation, num file, trace file, then node creation, then your agents, TCP as the agent, and then FTP as the application, then final program. Okay, same program you'll be able to get. But the only thing is that when you are going with a final year project, you cannot do this. You can implement only very simple programs by using this. You cannot create a very complex topology using this NSG software. But if you are too lazy in in typing all these things, then you can make this as the tool for creating at least the basics of your program. Now I'm going to save this. Save as I'll save this in the desktop. Okay, and nsg dot tcl. Whenever I have to save the file, I have to use nsg dot tcl. Okay, so I have done in save in. Okay, I will just save in home file. Okay, I'll just save in home file. So, Okay, nsg.tcl file is here. Okay, desktop you have a nsg.tcl file. Now I'm going to run this file. Control Alt T. Where I have to go? I have to go to desktop. cd T. This file is present in your desktop. Okay, this up to this it is going to be your home file, and after that you are having desktop. Inside the desktop you are having nsg.tcl. So I have to go to cd. Everything should be desktop. So in that I have to run this file nsg.tcl. So to run a tcl file, you have to type nsg.tcl. Okay, I'll just paste it here. Okay, in the desktop I will just paste. I'll just run it once again. Control Alt T, cd, desktop, nsg.tcl. Okay, if I'm running the program, you can see the program is been executed, and we can increase the speed of the sensor now. Okay, so 0 to 1, you will be able to see. Why it is been shown like this is because I think we have given the stop time as 6. We have not given it as 10, I think so. So that is why the simulation has been taken for only a small amount of time. Okay. I'll just show you once again. So this is the you can increase the speed of this. So this is the communication between 0 and 1. So both ways you are able to do the program. You can code it and you can simulate. At the same time, you can use NSG and create a network, and then also you can do it. Okay, so these are the two different platforms in which you can do the program, NS2 and NSG. NSG will give a graphical platform for you so that you will be able to drag and drop the files, and the TCL script will be automatically generated. But in case of NS2, you have to write the program by yourself. So as a beginner, you can go with NSG. But if you want to do some complex programs like a link failure or some routing algorithms, if you want to do, then for that purposes, you have to go with NS2. It will not work in NSG. NSG is just for your basic things. If you are a beginner, you can go with NSG. Okay. So these are the two different softwares which I tried to do. I think it is 12:30. So if you're having any doubts, you can ask. Okay. If you're having any doubts, you can ask. So this is the two platforms that I have tried to show you because with a limited amount of time, and I was able to do only this much. Okay, I'm sorry for that because I think it has been run a bit faster. But if you have any doubt, okay, if you are too interested in wireless sensor network and if you want to do a programming wireless sensor network, a project in a wireless sensor network, you can always contact me because I know that it is not possible to study NS2 within 1 hour or 1.5 hours. So if you want to do something more, then you can contact me at any time. I will help you. Okay.
Yeah, any questions from the student side? I think they are all hungry now, already 12:30.